In this video, we'll be talking about the supplementary units. The supplementary units are also known as the dimensionless units. They are also known as the dimensionless units. And when the SI was first established, it was defined by three categories of units. So it was defined by base unit, derived unit, and the supplementary units. So when the SI was first introduced, it had base unit, supplementary units, and third we have derived units. But the supplementary units were then removed in the SI units category, and since October 1960 it is now part of derived units. The supplementary units were removed, and they became part of derived unit since October 1960. Now, the reason, as I said it in the beginning of the video, that the supplementary units are also known as the dimensionless units. So the reason the supplementary units are called dimensionless units is because they don't have any physical dimension, and they have corresponding SI unit of measurement of 1. So they don't have any physical dimension. Where do I write? I think I write it here. Dimensionless units, because they don't have any physical dimension. Don't have physical dimension. And they have corresponding SI unit of measurement of 1. So here I'm just gonna write have one value of 1. Unit of measurement, the corresponding SI unit of measurement of 1. So we will talk through when I go through in detail about the units of supplementary units. We will then talk about these 2 points here, about having no physical dimension and have value of 1, because right now it won't make sense, and when I go more into detail it will all make sense. So the supplementary units actually comprise of only 2 units, which are purely geometrical units, and they are known as radian and steradian. So they have 2 units, only 2 units, which are purely geometrical, and these are radian and steradian. So these two were, as you know, they were formerly part of the supplementary units, and now these 2 units are part of the derived units. So first of all, we're gonna start with the radian. We're gonna start below. So the radian, written denoted by the symbol RAD, is the unit that is used for measuring two-dimensional geometry, which is plane angle. Radian used for two-dimensional geometry. Just gonna write 2D, two-dimensional. Now the radian is used for measuring two-dimensional geometry, plane angle. So plane angle basically means two lines that are intersecting at a point. These two lines given intersecting at a point. Two-dimensional basically mean two axes, which is the we in 2D we have x-axis and then we have y-axis. So plane angle basically means two lines that are intersecting at a given point. Now the radian is actually comes from taking the length of the arc of a circle, which should be equal, which is equal to the radius of the circle. As you know, radian is used for measuring 2D geometry. So in 2D, in two dimension, we have circle. So let me draw a circle. Let me draw it here. Oh, so here we have a circle, and let's consider this is the center of the circle here. I believe it's in the center, approximately in the center. So this is the center of the circle. So let's say, so the radian is the distance from the center to the boundary of a circle. So here, this is the radian here, radius, sorry, not radian, radius. So this is the radius. The radian says that the arc length of a circle, that if we take a part of the arc of the arc length of a circle, it should be equal to the radius of the circle. So if we, for example, we take this radian and we try to bend it according to the to the circle, and then we and then we intersect it right here, the section will be known as the radian. So for example, approximately taking this value, the radius here, the value, the measurement of the radius, and I think it's gone wrong here. Okay, if we take the arc length of here, for example, this arc length is equal to the radius of it. So now we intersect it again in the center. So this section here, this will be known as the this will be known as radian, as 1 radian. We take another color here, red. Okay, so this whole section, this whole part with this section that we took will be 1 radian. So the equation for radian is given by radian equal to S by R. So S equal to the arc length of the circle, and R is the radius of the circle. So basically we take the radius of the circle and make it and take an arc length of the circle, which should be equal to the radius of the circle, and the section that we get will be 1 radian of a circle. So the equation is going by S by R. S is the arc length of the circle and R is the radian of the circle, which should be equal to each other. Now for example, we are trying to measure the whole of the circle. How many radians will it take to complete a full circle here? Let me first draw. For example, we are trying to, instead of calculating 1 radian, we are trying to calculate the whole of it. That how many radians will it take to how many radians will it take to fill a circle? Then we will have the formula here. We will take the whole circumference of it, this one, the whole circumference of the circle, which will be 2 pi r by r. So r will be cancelled out and there we have 2 pi. So 2 pi radians will be equal to a full circle. Now which basically means that if I cut the circle in half, for example, if I cut this circle in half, then this will take pi radians to cover a half a circle, which is basically 180 degrees. So which means pi equal to 180 degrees and 2 pi equal to 360 degrees. So 2 pi radians equal to the whole of the circuit. We will need 2 pi radians for a full circle. Next we will have, and not to forgot to mention that 1 radian is equal to approximately 557.296 degrees. Now one radian equal to 57.296 degrees. Now we'll go to the radian, to the steradian, which is basically three-dimensional. So the steradian is denoted by the symbol SR, which is denoted by the symbol SR. And the steradian is used for measuring three-dimensional geometry, solid angle. For measuring 3D geometry, which is solid angle. So 3D means 3 axes. We have X, Y, and Z. X, Y, and Z axis here. Solid angle basically means a cone-like shape. You can say the two-dimension we have triangle, and if we consider 3 dimension of a triangle, we will have a cone-like shape, and that it is the solid angle. Basically like this. We have a cone here. So this is basically the solid angle. So the steradian comes from taking the area of a sphere, which is equal to the square of the radius of that sphere. So in 3D, we know in 2D we have circle, in 3 dimension we have sphere. So let's just roughly draw a sphere here. For example, this is a sphere, trying to make it 3D as possible, but I can't say it looks 3D. Let's say this is a sphere which is three-dimensional. So if we take area of a section of it, an area of the surface of a sphere, which it says the area of the sphere, which means the area of the surface of the sphere, not the area of the sphere whole, just the outside area of the sphere. So if we take an area, for example, this is the area, and this area should be equal to the radius of this circle, which is basically the from distance from the center to the boundary of the sphere. For example, this is the center of it, and these lines should be intersecting at the center of the circle. So this area will be, so this whole area will be known as 1 steradian, known as 1 steradian. This whole section will be known as 1 steradian, which is equal to the radius square of the sphere. So if we just take this section, pull that section out from the this section out from the sphere, we will have a figure that looks like this. We will have a figure like, for example, we will have roughly this kind of figure, this kind of figure which looks like a cone, and this will be equal to 1 steradian. So the equation for the steradian is given by equal to A by R square, where A is the area of the surface of the sphere, and it should be equal to R squared. So now, for example, we are trying to figure out how many steradian will it take to make a full sphere of it. So we know that the area of the surface of the sphere is given by 4 pi R squared. So the whole of the surface will be 4 pi R squared, and it will be cut out by the R square below. So we will have 4 pi. So it will take 4 pi steradians in order to make a sphere. Now the sphere is approximately, oh, not the sphere, 1 steradian. 1 steradian is approximately equal to 3282.8 square degrees. And now to mention those two points that I mentioned earlier in the video, they don't have any physical dimension and they have value of 1. What does it mean? So first let's focus on this one. Don't have any physical dimension. Not having physical dimension means that it doesn't have any dimension. Like in radian, we are trying to measure in length, it doesn't have any meter or feet. For example, if we have a meter, for example, here we have s is equal to the arc length, which should be equal to the radius of it. So if we take, for example, if the radius of the sphere is 2 meter, and the arc length should be equal to 2 meter. So 2 is cancelled out, and at the same time meter is also cancelled out. So we have 1 and we have no unit of it. So this basically means that it doesn't have any physical dimension. It's just like taking a ratio of something, of the same ratio of something. So also it also clears out the last fact, the last point here. It has a value of 1. So basically you can see radian, steradian, it basically says from the very start that the arc length should be equal to the radian, and the surface area of the sphere should be equal to the radius square. So if we take it, so which basically says that both values should be same, and if we try to divide these both same values, and we will always have an answer of 1, and we will have no unit. So I think that that is it, the video. And also one thing I also forgot to mention here, where is it? Okay, here I said 1 radian equal to 57.296 degrees, and 1 steradian equal to 3282.8 square degrees. So as you know, we are using degrees. It means that even if the circle is big or small, these two values will remain the same. Will remain the same no matter how big or small a circle or a sphere get. One steradian will be equal to 3282.8 square degrees, and one radian will be equal to 57.296 degrees. Why is that? Why? Because as you all know that a circle has 360 degrees, right? And even we make the circle small or big, it will still remain the same. I'm sorry, it's oval shape, but you get the point. Even if we make the circle small or large, if it will always have the same degrees, which is 360 degrees here. So I think that wraps up the whole video. So I hope you have found this video informative, and I'll see you in the next video. And don't forget to like and subscribe to my channel. And also, if you have any questions related to this topic, you can comment down below and I'll try to answer it for you guys. So thank you for watching, and I'll see you guys in the next video. Thank you.